Hi everyone, it's Joe here from Leading Edge. We're out in the shop today and we're going to be taking a look at some of our custom machine parts that we do. So in an earlier episode we talked about some of the common off-the-shelf parts that we do and some of the machining processes that I do for them. But for a lot of the parts in the mills and lathes we make, they're actually completely made in-house here. Pretty much every part that goes into these is either made in-house or worked on in-house with the exception of our sheet metal. So this is one of the parts that I've been working on today. I've been prototyping it and making sure all the tool paths work out. And this is our thrust bearing holder for our Z-axis on our milling machines. So we have two thrust bearings that go through here, one on each side. And this basically holds the lead screw in and makes sure everything is perfectly mounted for many years of good operation. So for ease of use, when we're manufacturing it here, we make it in two pieces and we have three of these bolts that go through and hold it all together. And that makes it, again, easier to manufacture as well as stronger too, because we can have more area in this bottom part where we can screw some other holes and anchor it into our column really well. So today I'm just going to take you through how like a normal part is made. And in the machine right now, David comes over here. We have the stock that we start out with. It's just 6061 T6 aluminum, 5/8 thick. And I got in the mill right now the program made up. So we do each side separately. We do a program for the top side and the bottom side. We usually start with the bottom first. And that's what we'll start with here. So let's get going. So we just took the first part that we were milling out of the mill, and this is the back side for our thrust bearing mounts. As you can see, we have all the holes drilled in there for the mounts, so all the various threaded holes, the lead screw hole in there, and then the through holes with a really tight fit for the bolts. We also counterbored a hole here for the thrust bearing, and we use a really precision counterbore in there. So every time it's perfect. We also, on the back sides, this is a personal thing that I like to do, and it's start doing the contour of the piece. A lot of times when you're doing a CAM program, you can just kind of drop all the parts from the front side, but I like doing like a little bit in the back side here, and that way I can run a teeny little chamfer bit around there and make a really nice little edge. So the next bit I'm going to do is these holes need threaded here, and that will allow us to bolt it to our fixture. So I made this nice little fixture here, and it indexes the parts perfectly in the mill every time, so we can do multiples really quick. And it indexes them just off of these bolt holes here. And I didn't have to put any extra holes in the material or anything, and it was real easy to do and really accurate too. It's indexable within about 1/2 thousandths every time, so that works out real well. So next I'll take it over to the tapping machine and put some threads in there. We have a head for the mill, but it was a little too, these holes were a little too big for that. So on smaller things we can do it automatically in our CNC, but for bigger things we got to use just a hand tap. So we'll do that next. Put the fixture in, and we'll start cutting the front side and dropping the parts out and be able to see the individual parts then. Here we have our final parts after we took them out of the mill for the last time. The only difference between these and this is these are still bolted to our fixture here, and the two halves are bolted together in this one. So a lot of the process was the same on the front side here as the back side. We still had our counterbore go in, and we still did our chamfering tool, but I'd say most of our time machining here was spent on actually cutting away the material around here to drop these parts out of the raw stock that we had. So for the most part, I usually like to try to get as many pieces as possible out of a single sheet. But here you can see we had some waste here and here. This was just aluminum that had to be cut away. And that's because the arrangement of these was just kind of a bit tricky to get in the right position. So like I said, most of the final finishing touches too were able to be done in the mill. We had a nice little 45-degree chamfer bit that we were able to put a nice chamfer on all edges here on the top and bottom. Remember, we did on the first side too, so there are no sharp edges anywhere, and it's a beautiful part. There's always a little bit that you still have to do by hand though, so for the most part, the only things I'll be doing is drilling some holes in the side here to anchor it to our Z column. Since we're only using a 3-axis, we are going to have to do that by hand. We couldn't do it in the mill process. And then I'll just use our little hole deburring tool and deburr our little threaded holes here. So there are a lot of parts we make for our mills and lathes, and it's kind of cool that we make everything here in-house. It's a really fun job to do. And so I'm glad I was able to take you along this kind of journey of how we go from just a bare sheet of aluminum to some of our parts that we make. It's pretty interesting, I think, and I hope you do too. So make sure you like and subscribe our channel, and I'll see you next time.